Okay, so what we're going to be looking at now is that we're going to be looking at linear equations. So we just talked about relations and functions and how this relates to a coordinate plane. So now we're going to take these and say, okay, what if I have a relation that is a straight line? Okay, what if it goes off in both directions, and for every domain value there's a range value, and it increases at a constant rate? You can think of this, a real world example of you being able to use some sort of linear function would be, hey, okay, you're going to mow this person's lawn for, $8 an hour. Okay? And every week they also give you $5, okay, as like a, hey, here you go, it's $5. Okay? So on top of the $8 an hour, you also get $5 extra for every time you do it. Now what you can do here is that you can write a linear equation to represent this. Your first time you'll get your $5, okay? And then on top of that you get $8 for every hour. Well, let's say you work 3 hours, okay? That means you would get 5 plus 24, okay? After that you can go, okay, what if I only worked, this is for 3 hours, okay? If I worked 2 hours, I'd get 5 plus 12. If I worked 1 hour, it'd be 5 plus 8. Okay? As you see, what's happening is that we're increasing by 8 every time we do an extra hour. Okay? So this is where we can use this. So the first thing we have to identify is our dependent and independent variables. Okay? So your dependent variable is the variable that is dependent on something. It's depending on something to change it. It's the one that will be changing. And that is your range. Your range is your dependent variable. It's changing based on your independent variable. And your independent variable is your x. Your x value, or the domain, is your independent variable. Nothing is affecting it. Okay? It goes off as time goes on. The larger it increases, it's not going to slow down or anything. Okay? Okay, so that's your independent variable. Usually your independent variable is time. Okay, that's a big one that's used for independent almost always, is time. Okay. Alright, so now your x and y intercepts. So your x and y intercepts are where you cross your x and y axis. So if you remember here, we have our x-axis and our y-axis on our coordinate plane. And let's say we draw this line. Okay, so I just drew a line through those two. This point right here, where it crosses the x-axis, is called our x-intercept. See? It goes together. X-intercept is where it crosses the x-axis. Okay? And that point is always going to be some number comma 0. Okay? And we just denote it as a comma 0. The y value at the x-intercept will always be 0. Okay? Now this point is your y-intercept. It's where it crosses the y-axis. And that point will always be 0 comma some number, 0 comma b. Okay? Because as you see, anywhere along this x or this y-axis, you always have an x value of 0. Okay? So your x and y intercepts are where they cross the axes. Alright, that's the first key in a linear function. Now the next thing is the slope, or the rate of change. Okay, they're both used almost interchangeable. And what the slope is that it's the vertical change or divided by the horizontal change. Vertical change all over the horizontal change, or the rise over the run. Okay, you've probably heard that. Rise over run. Vertical change over horizontal change. That is your slope, or the rate of change. Okay. Now the way it's written out is two separate ways. Okay, so the first one is just y2 minus y1 all over x2 minus x1. As you see here, this is one coordinate, this is another coordinate. So you've got to make sure that you stack those coordinates on top of each other when you do this. But the y's on top, the difference of the y all over the difference of the x. And then the other notation you might see is delta y over delta x. Delta is usually means change. Okay, so the change in y, or the difference in the y all over the difference in the x. Okay, that's what slope is. So if we want to find the slope of these, the first one we would go y value, -2 minus 4 all over, oh, no, that was a mistake by me. It would be -2 minus 2, because that's the y values, all over -2 minus 4. and then you would subtract those. -4 all over -6 gets you about 2/3 when you simplify. 2/3. Okay. And now the next one, you'll see we'll use the second one. So we'll use this point first. -9 minus the -3 all over 7 minus 0. 7 minus 0 is 7. On top, plus plus gets us a -6, which means we're probably at -6/7. Okay. So those are your slopes. Pretty easy when you're given your 2 points. Alright, so now we're going to look at two different forms. We're going to look at point slope and slope intercept. These are the two that are used a lot. Point slope is real nice because it's easy to use if you're given the slope on a point. You can easily put it into the function. And you can move from one to the other. Fairly simple. Alright, so point slope form. Point slope form has a point and it has the slope in it. Okay, that's why it's called point slope form. Pretty simple. So a line passes through a point, x1 y1. With a slope of m, you can use the equation below. Y minus y1 is equal to m parenthesis x minus x1. So if I said that the slope was 3 and I have a point 4 comma 2, all I'm going to do is I'm going to plug this in for the m and this in for the x1 and this in for the y1. Now this you're going to have two variables. You have y, so I'm going to have y minus 2 is equal to 3 comma x minus 4. And there you go. There's point slope form. Done, you know. Wash your hands of it. It's easy. Slope intercept form is a little bit different. If you're given the y-intercept, so if I were to say that the y-intercept, or where it crosses the y-axis, is at 4, okay, and the slope is 3, again, this right here is your b. So you can write this function as y equals 3, the slope, x plus 4, or the y-intercept. So if you're given the y-intercept and the slope, you use slope-intercept form. That's why it's called slope-intercept form. Okay, but this is the y-intercept that you plug in for the b. Okay. All right. So now let's say you're given 2 points. So I have these 2 points, 3, -4, and 4, -2, and I want to do point slope and slope-intercept form. Well, point slope is going to be the easier one. First thing we have to do is find the slope. So I'm going to take the y's, -4 minus -2 all over 3 minus 4, which would get me plus plus, -2 all over -1, which gets me 2. So my slope is 2. So I'm going, for point slope, I've got y minus, and then I'm going to use the first point. So it'd be y plus 4 is equal to 2 parenthesis x minus 3. And I'm done. There's point slope. Now if I want to turn it into slope-intercept form, all I'm going to do is simplify it and get the y by itself. So I'm solving for y. So y plus 4 is equal to 2x minus 6. I distributed. And then I subtract 4. Subtract 4. Y equals 2x minus 10. And that would be my slope-intercept. Okay? Done. And as you see, you could use either of these points to get your answer. Okay, perpendicular and parallel. If you want something that has a perpendicular line to another function, so if I give you something and I say, or give you a line and say I want something perpendicular to it, the slope is going to be the opposite reciprocal of it, which means if I give you a slope of 7, the opposite of it, okay, the opposite of it is -7, and the reciprocal is -1 over 7. And the way to check to see if it's parallel, or to see if it's perpendicular, you take your original slope, multiply it by its parallel, and it should always equal -1. If that's the case, it is perpendicular. And then after that, you take that, you plug it back into the function, and then you find your missing parts for your new line. Parallel have the same slope. So if you have a slope of 7 and you want a parallel line, it's going to have 7. All right. So if I wanted to take this and I wanted to find the perpendicular and the parallel lines for this function up here through this point, right, what I'm going to do is, the first thing I have to do is find the slopes. And the slope, again, this is in point slope or slope-intercept form. So there's my slope. So my slope is 2/3. Now if I want to find the perpendicular, as I said previously, the perpendicular is the opposite. Okay, so it's the opposite, which would be negative 2/3, and then it's the reciprocal, which will put us up at negative 3/2. So there's your new slope. Okay. Now if I wanted to go through this point, I can use point slope form. It'll be easiest, quickest. So it'd be y minus 1 is equal to our new slope, negative 3/2, parenthesis x minus 2. And there is my perpendicular line to this one. Now if it's parallel, right, I keep the same slope because parallel lines have the exact same slope. So I'm going to go y minus 1 is equal to 2/3, parenthesis x minus 2. And there we go. Pretty simple. Alright, so now your IRAT. What you're going to do for this is you are going to use these 2 points, 2, 4 and 3, 8. And I want you to find the slope-intercept and the point slope form made by these 2 points. Okay, so you're going to have to find the slope. And then, after that, I want you to write the line of the function of the line that is parallel to that one through the point 4,6 and is perpendicular through the point 3,7. Okay, so you should end up having 4 functions here, 2 that are exactly the same, and then the 2 separate ones. These bottom 2, the lines that are parallel perpendicular, you can use either form. You can use point slope or slope intercept. Right, either one, whichever one you feel more comfortable completing. Okay, but I need to have the original one in point slope and slope intercept. All right.